Hi there, it's Miss Adams from Flamingo Math. We're continuing today in conic sections. We're going to talk about the definition of an ellipse. If you look down here at the bottom of the handout, you can see the two visuals that we can look at. The equation that has the major axis on the horizontal orientation has x squared over a squared and y squared over b squared. But if our major axis has a vertical orientation, notice what happens to the denominator. Here, x squared over b squared and y squared over a squared. So the a squared is under the y, and here the a squared is under the x. We could say that here a is greater than b, and that a squared is the largest in each case. Now, we also need to pay attention to how you find the focal points. So on the major axis is horizontal or vertical, we're going to use a Pythagorean relationship, and we'll find that C value, where those focal points are located, by taking the square root of the difference of the squares of A and B. Let's go practice with a fairly simple one. Here you notice x squared over 25. So when x squared has the larger number, a squared is 25. If a squared is 25, the a is going to be 5. And b squared is 9. That's going to go up and down. The b value is 3. And we are finding the focal point by doing the relationship. C is the square root of a squared minus b squared. So 25 minus 9 is the square root of 16. Our C value is 4, and the C value goes in the same direction as the A value. That means we have a horizontal major axis. There's no H and K yet, which keeps our center at 0, so you can put a little dot there. But you want to go 5 units right and 5 units left. We want to go 3 units up and 3 units down. This creates the elliptical shape. Oh wow, I did that really well. And then I want to make note of where the focal points are. So the focal points are 4 units away from the center. Let's label them here as focal point number 1 and focal point number 2. What are the ordered pairs on our major vertices? That would be this point, -5, 0, and then the one on the right at +5, 0. Those are called major vertices. The minor vertices, that's not sliding. Our minor vertices are the ones going vertically up, so 0, 3, and 0, -3. And then our focal points, the first focal point is -4, 0, and the second focal point is at 4, 0. So that's not too hard. Let's go on to example 8. Here we want to find the equation in standard form for an ellipse who's got a focal point at 0, 3 and 0, -3. If we put those on our graph right away, that'll help us know where the orientation is. And you'll notice that the vertical orientation, since they're both sitting here on the y-axis. What else do we know? We have a major axis that's length 10. So if the major axis is length 10, that's the A value. A is the largest number. If A is 5, then A squared is 25. So we've got A being 5, and it's got to go in a vertical orientation because we figured that from our 2 focal points. So if we go 5 up and 5 down, and we want to find the center we knew was at 0, 0. And what do we know about the focal points? They're at 3. So that's going to leave this going up. The B value has to go left and right. And that should leave C being 4 because, again, 25 minus 9 is the square root of 16, and the square root of 16 is 4, which puts the points to the right. So it's basically the same ellipse, just oriented in a vertical fashion instead of a horizontal fashion. All right, the major vertices are going to be on the y-axis this time, 0, 5, 0, -5, and the minor vertices are going to be on the x-axis, -4, 0, and +4, 0. So those are some basic ellipses. Let's look at example 9. They're going to give us the graph, I believe. No, they're going to give us an equation. We're going to solve the equation for standard form. So that's just a little bit of algebra. Let's think about this. 9x squared 36y squared equals 324. We want this equation over here, the right term, to be 1, so we need to divide every term by 324. So 324 divided by 9 gives us 36, and 36 goes into 324 9 times. 36 times 9 is 324. Our center is at the origin. Our vertices are going to be on the horizontal because this is our a value. A squared is the largest, and b squared is next. And we'll find the c by doing the square root of a squared minus b squared. So the major vertices are at 6. A is 6. Let's write this down. A is 6. B is 9. And C is the square root of 27. So 9 times 3, that would be 3 square roots of 3. And we have our major vertices at 6, 0, and -6, 0. We have our minor vertices there at, the b value was 3, wasn't it? I wrote 9, that's wrong. The b value is at 3. So we go up 3 and down 3. That gives us an ellipse horizontally oriented. And then 3 square roots of 3 is a little bit more than, let's see, square root of 27, so a little bit bigger than 5. Minor vertices are at 0, 3, 0, -3, and if we go a little bit bigger than 5, we'll call that focal point 1 and foci 2 over here, and labeling those appropriately without decimal values. We have 3 square roots of 3, comma 0, and -3 square roots of 3, comma 0. So we got all of that taken care of. Next, we want to try something a little more complicated. We're going to move or translate the equations where the center is at HK. Now, what can we know about these situations? Here I see same thing. If the a value is under the x, we have a horizontal orientation. If the a value is under the y, we have a vertical orientation. And I'm not going to talk about memorizing things. We can use the equations and the properties to figure out where items are located. In this case, we want to divide each term by 36 to get the right-hand side of the equation to be equal to 1. 9 divides 36 4 times, and 4 divides 36 9 times, and 36 over 36 is 1. So our a value is under the y because it's the bigger value. Under the y, we have a vertical major axis. The a value, a squared is 9, so a is 3. Our b value is going to be the square root of 4. And then how do we find c is a squared minus b squared. We want the square root of that. That's the square root of 5. It goes in the same direction as the a value. Square root of 5 is going to be a little bit bigger than 2. Okay, without getting a calculator. H and K. H belongs with the x. So if x plus 3 is 0, our x is negative 3. And K belongs with the y. If y plus 2 is 0, our y is negative 2. That puts the center at negative 3, negative 2. We can go plot that on our graph and then use our A, B, C values to get the other points. Negative 3, negative 2. This is our center. We're going 3 up from there. So 1, 2, 3. And 3 down from there. 2 to the right. And 2 to the left. And this is our ellipse right here. Our focal points from the center is a little more than 2 in both directions. And this will be the first time when I can show you what I'm talking about instead of memorizing all of those formulas and driving yourself crazy. We can use the graph to help us out. So where are our major vertices? One is at negative 3 major vertices. Negative 3, positive 1. So negative 3, positive 1. And the other one's down here. Negative 3, negative 5. The minor vertices are on the horizontal here. So at negative 1, negative 2. And the farthest one away is at negative 5, negative 2. So here's what I'm talking about to get to the focal point. If you start at the center, you're going to go from the origin, you're going to go out negative 3 and down negative 2 and then back up to the F1 point. You follow that? So we went negative 3, negative 2, and we went backwards. So we added back or subtracted. What did we do? So we went negative 3, and the center was at negative 2, and then we had to add back the square root of 5, and that put us at the f sub 1 point. But this second f sub 2 point, we went out to negative 3, we went down on y negative 2, and we kept going in a negative direction, square root of 5. You see how that put us at the f sub 2 point? So if you look back at that equation on the previous screen where it says, if I want to find the foci, I do H and K, and I add and subtract the C value. Just looking at the graph is a much easier way than trying to memorize that to get these two ordered pairs if you needed to write the ordered pair. Just takes a little practice. On example 11, where this is our last one, it's another completing the square. We're going to prove this graph is really an ellipse, and then we're going to find all the details. So we want to group the x terms together, 4x squared and negative 32x, and we want to leave a little space because we're going to complete the square in a minute. And then we want the y squared and the y term together, And we're going to have to complete another square. That's what it means by completing the square twice. And then subtract 124, and we'll have to add two numbers to the right side because we're adding two numbers over here to the left. If you remember from Algebra 2, you can't complete the square if the leading term is not 1. So we're forcing the leading term to be 1. And then completing the square, half of 8 is 4, and 4 squared is 16. So we want to add 16 to the left, and we'll add 16 to the right. Then the next term, we do have a positive 1. So completing the square again, half of 16 is 8. 8 squared is 64, so we want to add 64 to the left and to the right. Now we're going to factor both trinomials. So x minus 4 squared would be our first one, and y plus 8 squared would be the second one. And adding all of this up, what do we get? 4. Okay, so divide by 4 so that we have x minus 4 quantity squared over 1 plus y plus 8 quantity squared over 4 equals 1. This is our standard form. That's telling us everything we need to know. The h value is with the x. The k value is with the y. And what do we know about this? We know that a is the square root of 4. B is the square root of 1. And c is the square root of 4 minus 1. So that's square root of 3. Now, if you wanted to get some graph paper, we would have the major axis is on y. So we're over here at 4, negative 8, way down here. And we want to go 2 up, 2 down, and then 1 right and 1 left, and 2 up and 2 down. So it's going to be some little thing down here. So major vertices, 2 up, so 4 and negative 8 plus 2, and 2 down, 4, negative 8 minus 2, and then right, so 4 plus 1, because we're going right 1, 4 plus 1, keep the negative 8, and 4 minus 1, keep the negative 8. See how I'm just figuring that out without memorizing all of those h and k and plus and minus c. The focal point, again, we're going to start at the origin. We're going to go out 4. We're going to go down 8. And then we're going to keep going down square root of 3. So we got 4. We went 4 on x. We went down 8 on y. And we subtracted the square root of 3. To get the other one, we're going to start at the center, go out to 4, go down 8, and then we're going to add back the square root of 3. So 4, go down 8, and add back the square root of 3. That, my friends, is how to graph a transformed ellipse. One more conic section to go tomorrow. See you then.